The primitive types for numbers are limited, so in some case you'll need to use other classes that Java provides. This video will show you one such class and then how to find them. The documentation that comes with Java is useful, and there's a trick to generating that same kind of documentation for our own code. By definition, our primitive types have to have fixed capacity because the compiler knows how much space to give them. Sometimes we need to be able to hold numbers that are even bigger or even more negative than a long can hold. To do that, Java gives us a class named BigInteger that can hold integers that are arbitrarily large. It's important to think about the fact that something that is arbitrarily large would have to be an object. It has to be a reference type because primitive types have fixed sizes so the compiler can allocate the space. Since we need this to be arbitrarily large, it can't be primitive. Now let's think about the three meanings of the word class when it is used in that sentence. Class can be a new type we're defining. Since BigInteger is a class, we can declare variables to be of that type. Class can be the set of objects of that type. And finally, class can be the code that is a template for making objects of that type. That means somewhere there is a source file named BigInteger.java that has the code that creates BigInteger objects. This code is just like our code, and we can go find it.
No doubt, Merlin's going to show that code to you. Don't let it overwhelm you. The point is just to see some real code. But certainly, you don't need to be able to write code like this. You don't even have to be able to read most of it. Just wander around with her.
This is the code for BigInteger. Here's the class declaration. We should be able to find things just like the things we put in our classes. A big integer needs to know what number it's holding. Well, here's an array that's going to hold the individual digits of our number. That's how it can get so big. We can allocate an array to hold a lot of digits.
Technically, it isn't totally unlimited. There is a limit to how much memory the JVM gets. But who would need to hold an integer bigger than that?
The other thing it needs to know is the sign of the number it's representing. That's stored in this instance variable. Notice that the sign is either +1, -1, or 0, and that if the big integer is holding a 0, the sign must be 0. That's because they don't want a positive representation of 0 and a negative representation of 0, because there's only one of them. One thing big integers need to do is to add. Let's see if we can find that. To do that, I'm just going to do a find in this website to get to the code. Here it is. Boy, that isn't what I expected. This class is using a machine-specific class that comes with the JVM named BigInt that does the addition, because how we add can depend on the machine we're running on. The point is, there are methods for what big integers need to be able to do. Wading through the code is a very difficult way to figure out what methods are available. The lab tells you to go out and find the Java API, which stands for Application Programming Interface. You should do that. It looks like this. In order to navigate easily, let's click on Frames. Up here, it shows you all of the modules, and the module for all of the classes that we're going to use is java.base. Now there are packages, and package is a group of classes that are related to each other. Our particular big integer class is in java.math. If you click on that, you can see the other classes that are in that package. And if I click on big integer, it shows us the documentation for the big integer class. So it starts with a description at the top of what the class is. And then you can see a summary of all of the constructors for the class and a summary of all of the methods for the class. This is our add method. So if I click on that, it gives you more information about exactly what that method does. This is the way you find the things that Java gives us for free. Documentation like this might look like it's really hard to do, to make, but there is some magic that goes on. Look at this description of the class in the Javadocs, and then look at the top of the source code. Immutable, arbitrary precision integers, yada, yada, yada. It matches. So there is a magic program called Javadoc that takes these special comments from our code and generates the documentation for us. These comments are called Javadoc comments, and they have a specific format. A Javadoc comment must immediately precede the thing that it's documenting. There can't even be an empty line between them. They start with /** and end with //. Inside the comment, the first sentence is what will go into the summary section of the documentation, and then the full description will go in the more complete section of the documentation. If you want, you can embed HTML formatting in them to make the resulting web page easier to read. In addition to the description, there are a set of block tags to add specific kinds of details. Let's look at an example to see how this works. So this is a board class from a battleship game. And you can see up here, right above the class, this is a Javadoc comment because it starts with /// and ends with /*. And since it's right above the declaration of the board, it's describing that board. And you can see there are other Javadoc comments further down here. As an example, here is a method that apparently checks to see is there a boat at a particular position. And you can see it has a description, and the first sentence is a summary. That'll go in the Javadocs where the summary is. And then the complete English will go in the full description in the Javadocs. And then it uses these block tags to describe extra things. So in particular, we're using the param block tag to give a description of the one parameter that we have. And we're using the return block tag to describe what exactly gets returned by this method. Once you have these kinds of comments, it's really easy to generate your Javadoc comments. You just go to project and say generate Javadoc. I want to do it for this project, this source file, the default package, and I haven't done all of the rest of them. I'm going to show you this particular one, the board class, and say finish. And it does a pile of work, and you see now we have in my project there is a doc directory, and if I looked at the root of it, here is the root of my thing. Here is the class board, because that's the only one that I did. One constructor. Here's a summary of my methods, and here's that boat at position. The first sentence is the description that's here, and when I click on it, the full description is here, and the descriptions of the parameters are here. And that's all in HTML files. You could publish them to the web really easily. In this video, we looked at one of the many classes that Java gives us to help build our systems. BigInteger is a class which will hold arbitrarily large integers, and you'll use it in this stage's lab. The way we find these free classes is by looking at the Java API, which has detailed descriptions of them all. That type of documentation is generated from code when we embed special Javadoc comments in our code. And we can do that with our code too. Then we can use the Javadoc tool to translate those comments into searchable documentation. The real power of this comes from the fact that the comments are right next to the code they describe. That makes it easy for developers to remember to update them. So it's much more likely that the documentation will stay up to date when compared with documentation that is stored in separate files.